So hi everyone, welcome to my YouTube channel. In this video I am going to explain you about the experiment on J by electrical method, that is calculation of Joules constant with the help of electrical method. So here we are going to use Joules calorimeter. So let us study how to find out J value by electrical method. So here you can see the apparatus required for this experiment. This is the step down transformer, and here is the wooden box where inside that we have the Joules calorimeter. I am going to show you, and here is the thermometer to note down the temperature, and this is the rheostat, ammeter, voltmeter. So the voltmeter range is from 0 to 3 volt. Then each division if we take, so this is the range of 0 to 0.5 volt. So then one division is equal to 0.5 divided by 10, that is 0.05 least count. And here is the ammeter of 3 ampere range. So here also one division equal to 0.05 ampere. And here is the stopwatch to note down the time, and here is the one-way key, and here is the weighing machine to weigh the Joules calorimeter with water and without water. So first let us know this Joules calorimeter which is inside the wooden box. So here if I will take this thermometer outside, and inside this wooden box, so inside this wooden box we have the Joules calorimeter. This is the copper vessel. Okay. So we have to weigh this copper vessel with the help of weighing machine. So we should note down the weight of this Joules calorimeter. Without water we should note down, and when you pour water into this, again you should weigh the weight of this calorimeter. So we have to insert this within this wooden box, and here if we see, here is the spring. So I will take this outside. So here is the coil we can see, so which is connected across the voltmeter in parallel. So then this is the stirrer we have. Water into this, within this spring the charges are going to flow, and which is kept inside water. And this is the stirrer we have to use to stir the water. So first we have to make the connections according to this given diagram. Here is the wooden box. Inside that there is a copper vessel. We have to pour water into that. This is the heating coil, and these are the two terminals of the heating coil, across which we have to connect voltmeter in parallel to that. And here is the thermometer to measure temperature across the water, and this is the stirrer to stir the water. The common terminal of this heating coil and voltmeter must be connected to the positive terminal of battery. Negative terminal of the battery should be connected to positive terminal of ammeter. Negative terminal of ammeter must be connected to one end of the jockey, and another end of the jockey must be connected to the rheostat lower end. The head of the rheostat is connected to the common junction between voltmeter and the heating coil terminal. This is how you can complete the connections with the help of this diagram. So first we should know how to make the connections here. First we have to consider the step down transformer. So here we can see the range of the step down transformer 0 to 12 volt, and the positive terminal of this step down transformer must be connected to the one end of the coil, which is inserted inside the collimator containing water. Then another terminal must be connected to the head of the rheostat. So this must be connected to the one-way key from rheostat to the another end, lower terminal to the one-way key, and then another end of the one-way key to the positive terminal of ammeter, negative terminal of the ammeter to the negative terminal of this step down transformer power supply. Then voltmeter must be connected in parallel to the terminals of the coil, which put inside this collimator, and we have to note down the temperature across this collimator containing water with the help of thermometer. So here is the stopwatch to note down the initial time of the thermometer and as well as when the temperature rises. So here I have written the aim of the experiment to determine the value of mechanical equivalent of heat J by electrical method, and apparatus required are mentioned here, and I already shown you which are the apparatus required. So this is the formula to calculate value of J, that is given by voltage into current into time divided by mass of the calorimeter and the specific heat of calorimeter, mass of the calorimeter with water, and specific heat of calorimeter into initial and final temperature difference T2 minus T1. Unit is joules per calorie. First you have to switch off the step down transformer, then you have to adjust the ammeter reading to 1 ampere with the help of rheostat. Okay, then corresponding voltmeter reading you can note down. Once you got the value of 1 ampere by adjusting rheostat, then you can start the timer. So you have to keep the experiment for 20 minutes. Initial temperature you should note down once you are going to start the experiment. So initial temperature, how much you will get, you can write down in the observation, and then for every 2 minutes, interval of 2 minutes, you should note down the value of ammeter reading, voltmeter reading and thermometer reading. Okay, then you can tabulate the values in tabular column. So here are the observations for this experiment. So here the observations include maximum 10 to 11 observations are there. So first, least count of thermometer. Usually if you use the thermometer, the least count is 0.5 degrees Celsius, and least count of ammeter, as I shown you the ammeter, the given ammeter has the least count of 0.05, 1 division ampere. Least count of voltmeter 0.05 volt. Mass of the calorimeter, if you weigh, practically if you are doing, you can note down the mass of the calorimeter along with stirrer. So here the calculated value is about 176 gram, and mass of the calorimeter with stirrer including water, that is 374 gram. Mass of the water, if you want to calculate, you have to subtract in 374 minus 176, then you will get the mass of water 198 gram. Initial temperature of water, when you start the experiment, you have to note down the initial temperature, that is how much you get, you should note down. So here the value is 18.1 degrees Celsius. So final temperature T2 around 20 degrees Celsius. So time for which current is passed. We have kept this experiment for 20 minutes. So in 1 minute 60 seconds, 20 into 60, 1200 seconds. So specific heat of water, that is the standard value 1 calorie per gram degree Celsius. So specific heat of calorimeter, that has been calculated. If you perform the experiment, you can also do the calculation for specific heat, and the calculated value is 0.1 calorie per gram degree Celsius. So here is the tabular column for this experiment. So you should note down the time you have kept for 20 minutes. So for interval of 2 minutes, you should note down the temperature, corresponding voltage and current reading. And then once you note down the value of temperature, voltage and emitter from 0 or 2 minutes to 20 minutes, then you should take the average of voltage and average of current. You should write down in this column. So the average value of voltage, we got about 1.1 and here current 1.2. Next, using this formula, you can calculate the value of J. So average value of voltage 1.1, average value of current, and then the time taken in terms of second, mass of the calorimeter with stirrer, and specific heat of calorimeter, and mass of the calorimeter with water, and specific heat of water, initial and final and initial temperature. Then you will get the final result, that is 4.08 joule per calorie. So it is nearly equal to the standard value. The standard value is 4.12 joule per calorie. So this is how you can perform this experiment.